This is lesson 5.3, solving exponential word problems. Now, you already know how to solve basic exponential word problems using the formula that you learned for exponential growth and decay, where A is what you started with, R is the decay or growth rate, usually given to you as a percent, and X is the number of time intervals that have passed. Now, pause now and make sure that you have these two formulas, even if you knew them before. Now, in this lesson, we're going to look at some special exponential equations. The first is compounded interest. Now, exactly what do we mean by that? We mean we're going to start with some amount of money, P dollars. And A is the amount in the account after so much time has passed, or so many years. R is the interest rate that your money is going to be compounded by, and N is the number of times a year that this compounding happens. So this is the formula. Make sure when you do take notes on this that you have this formula and that you have all of these piece parts labeled. Now, what do we mean by number of times a year? If something is compounded annually, then it's compounded once a year, and then N would be 1. Another example is if it's compounded quarterly, then that means it's compounded 4 times a year, and N would be 4, and so on. As you take notes on this slide, make sure that you have these times, N, these number of times of year, well documented in your notes and that you understand them. So pause now and take notes on this slide. Now, the first example for compounded interest is this. We have a certificate of deposit, better known as a CD, for $500 that is going to earn interest at a rate of 4.25%. It's compounded monthly. How much do we have at the end of 3 years? So this is our formula, remember. So we're going to identify all of the variables that we can in this formula. Now we're looking for A. How much do we have at the end of 3 years? Our beginning amount is $500. Our interest rate is 0.0425 or 4.24% or 4.25%. It says it's compounded yearly, monthly, so N is 12, and we're talking about a 3-year period, so the amount of time that's passed is 3 years. Now we're going to plug all those things in, like so, and they're color-coded so you can see exactly what we did. And we're going to put all of that in our calculator or in any calculator and get the answer that at the end of 3 years, we're going to have $567.86 in our certificate of deposit. Pause now and write down this example. Here's example 2. How long will it take $30,000 to grow to $110,000 if we put it in a trust that earns a 10% annual return that is compounded semi-annually? Now we're going to round to the nearest tens. So okay, here's our formula for compound interest, and in this case we are given P, we are given R, we are given the number of times this compounding happens semi-annually, so that's twice a year, and we are given A, the final amount we're going to end up with. What we're being asked to find is the time, T. So let's get busy and do that. So let's plug in everything that we know. Now, we end up with an exponential equation that we need to solve for the exponent. So we're going to start by dividing both sides by 0. Why? Because we want to set this up so that we can take the inverse, find the inverse of this exponential equation, and then solve for t. So we're going to simplify 110,000 divided by 30,000 to 11 over 3. And then we're going to find the inverse of that expression. So our base was 1.05. The output of our previous expression becomes the input for the log, and the input here becomes the output of our log. Now we can solve for t by finding out what this number is and dividing it by 2. And so we find that the amount of time that has passed is 13.3 years. That's how long it will take for $30,000 to grow into $110,000 if we earn 10% annually, but it's compounded semi-annually. Pause now and write down this example. Now there is a different kind of compounded interest, and that's continuously compounded interest. If I were investing, this would be the situation I would want every time. Now in this case, A is how much we end up with after t years, and t is years, of course. R is the interest rate, usually expressed in a percentage, and of course P is what we started with, and E is the constant E, Euler's number. Now, let me go back. Make sure that you have this formula written down and that you have defined everything in the formula. Now, our first example here is, again, our $500 CD that earns 4.25%, but now it's compounded continuously. So we're going to use this formula. A is equal to P e to the RT power. All right, so we know P, we know R, we know T. Let's plug everything in and see what happens if we use our calculator to calculate A. We'd find out that if it's compounded continuously at the end of a 3-year period, we'd end up with $567.99. Pause now and copy this example. The second example, how long will it take $30,000 to grow to $110,000 if we have a 10% annual return compounded continuously? And we're going to round to the nearest year. Okay, so here's our formula again. Now we were given, in this case, A, the final amount that we're shooting for, P, our starting amount, $30,000, our interest rate, 10%. But we don't know T, so we're going to solve for T. So let's set this up. Let's plug in everything we do know, A, P, and R, and then we're going to divide both sides by 30,000 and simplify. Now we have an expression that we can find the inverse, that we can use to find the inverse and then solve for T. So we set this up, because it's E, we set this up as a natural log and not a log. And remember that natural log, or ln, is log base E. Same thing as log base E. So now that I have this set up here, I have 0.10 t is equal to the natural log of 11 over 3. This is a number. I can plug this into a calculator and figure out what that is and divide that by 0.10, and I will have solved for t. So I'm going to do that here, and it turns out that it will take about 13 years to accumulate $110,000. Now, when do you use continuous compounded? When do you use this formula? When the problem says something is compounded continuously. You use this particular formula. Now pause now and write down this example. The last special equation that we're going to look at is exponential growth and decay. Now again, P here is the amount we're left with after time t. Let me back up. Let's talk about P sub 0. That's the initial amount. And K is the growth or decay rate. So you would recognize those. Now here's the special thing. If K is positive, then it's growth. If K is negative, then it's decay. Now this is often used for radioactive half-life measurements or measurements of bacteria growth, that kind of growth or decay. Pause now and make sure that you have this formula and everything in it defined. Now the first example of that, we have a bacteria that has an exponential growth rate of 25% a day. Now we're starting with a half a gram, and in this scenario it's theoretical, so no limitations on resources. How much bacteria can we grow in 2 weeks? And we're going to round this to the nearest hundreds. So okay, we're going to use our formula here where the black P is what we end up with. P sub 0 is what we started with. You know that E is Euler's number, and K is our rate of growth or decay. So we were given P sub 0, our starting amount, we were given K, and we were given T. So we're going to plug those things in and use a calculator to figure out that we can grow 16.56 grams in 2 weeks. Pause now and copy down this example. Now, if you are in a pre-AP class, you have one more example. If not, you are done. Please note your questions and come to class ready to work with your notes. If you are in pre-AP, the second example is of particular interest. Again, we go back to our scenario where we have $30,000 to start with, and we want to grow that to $110,000 in a trust that earns 10% annual return compounded semi-annually. So let's see how this is going to work. Here's our formula. Now, we were given the, this isn't the right problem. I'm not sure what happened here. I will go over this problem in class. Leave a space for it in your notes. But I do want to work the problem anyway. We were given a P of 75. We were given a starting amount of 150 and a T time 4.2. So the first thing we have to do here is find K. We really have everything else. We have to find K in order to answer the question that you do not have here. But bear with me. All right, so we're going to plug in everything we have and then solve for K. Now in this case, we'll need to divide both sides by 150 and then take the inverse of that in order to solve for K. So we end up doing that. We have 4.2K is equal to the natural log of 1/2. We divide both sides by 4.2 and we determine that K is negative 0.165035. Now what do we do with that information? We take that information and we plug it back into our original equation with T. So I'm going to roll through this. Please write down these calculations. And I will give you the right word problem to go with this in class. I do apologize. I'll see you in class.